Yes,
We're
we
live.
are live. Oh, wow. Hello.
Oh, wow.
I mean, it's always feeling exciting once we do this, like hitting the live thing. We've done this now
One.
21 times.
Well, you've done it 21 times. I've probably more in the 17 range.
Maybe, yeah, but you've been here a lot, so still. And I have to say, it has been a really interesting week. You've been in Amsterdam, I've been in Berlin. We run the Hack Night. We had a lot of, like, we had some improvements to our code generation platform. And I know that there is a lot of magic happen behind the scenes or in the code. And I think there were two things that we improved majorly from the last time. And I think the first one is that people can now create applications on CodeGen with any package that is supported on Cloudflare Workers. And we
Yeah.
had to do some magic in the background there. And I think the other one is we fixed our rate limit problem we ran into the last time. And I would like to, yeah, I don't know. I'm interested to know what did we do? How did we fix those? Well,
Yeah. Okay. So the problem we were trying to solve, so the last hackathon, we could theoretically work with almost anything that would work on Cloudflare Workers. It's just that the type checker would fail. So sometimes the agent would see that the type checker was failing, and then it would go ahead and just like remove the package or something like that. So that was a little problematic. But then there was a secondary problem, and I said almost before, because what happens when you bundle a Cloudflare worker, typically that goes through Wrangler, which is the Cloudflare CLI. And Wrangler looks at your configuration for the worker, and it does a lot of transformations to the code based off of your configuration. And it also transforms your dependencies to make it work in workerd, which is the Cloudflare Workers runtime. The thing that was breaking for us, so we had 11 labs at the last event, and we couldn't use their SDK because we were not fully replicating what Wrangler does to do something called polyfilling of certain Node.js built-in utilities. That's a very
what is
loaded
polyfilling?
sentence.
Can you not polyfilling? Haven't heard that. Can you explain that
Yeah,
to me?
it's funny to me. Polyfilling is kind of like I feel like it's a very popular, like in the JavaScript world. It's like because JavaScript can run in all these different places,
Yes.
and you're not guaranteed the same like standard library or built-ins across all of those places. And so polyfilling refers to if you want to use an API, so like a library, standard library or what have you, that exists in one place but doesn't exist in another, you can polyfill it, meaning you just make up the implementation if it's not there. And the interesting thing that Wrangler does is it has to be very selective about what it polyfills, because workerd does implement some of Node.js's built-ins, and it just doesn't support others. And so at the end of the day, you have this kind of complex strategy for what things get polyfilled, what things get shelled out to the runtime, and we weren't following that strategy faithfully. And so we had to do a very significant rewrite in the days leading up to the event to make that work. And then now you can use packages like 11 Labs.
That's super cool.
Yeah.
And that's also like, is that also like you mentioned that, right? That's also where we used durable objects and R24 or
Kind of. Yes, it's
kind of.
related. So that was a bit more. Wait, I don't know how interesting this would be. I created a mermaid diagram.
That's perfect because I wanted to ask you, can we have a whiteboard and you draw something because just
Yeah.
talking is sometimes harder, but
Let's see here. Wait, can I color theme? Rosé Pine Dawn. Ooh. Let's see if this works. All right, that's a little easier to read. Okay, so the main thing that was kind of interesting from a Cloudflare perspective. So to back up for a second, what we needed in two different places, we needed all of the packages that were going to be bundled with whatever app someone was creating on our platform. And those packages can get quite large when all together. And especially they can get large when you're downloading so typically you would have to fetch the package, which gives you a compressed file, and then you'd have to decompress that file, and then you'd have to get all of the package files that you need from there. And if you do all of that in a worker for every single package, the worker will sometimes crash. And so that's the thing the week before that we were like, oh, let's try it. We'll get to the ways to improve this at a certain point, but we couldn't do streaming parsing, which now I think we do have a solution for that. And so that meant we were loading tons of stuff into memory. And my first stress test just like broke the thing that was downloading packages. So we had to go back to the, I don't think we actually whiteboarded it, but we had to go back to the proverbial drawing board. And we had to think of, okay, so in this memory constrained serverless Cloudflare world, how would we download and save packages so that we have access to, on the one hand, the type declaration files that are necessary to do TypeScript compilation, and on the other hand, to the files themselves when we actually want to go and bundle the application. What we settled on is like a durable object per package and version, and a durable object instance. And so this is a really cool use of durable objects because they have enough memory, unless you do like a very wild package like Puppeteer that bundles Chromium or Chrome in it, you don't really hit memory limits if you're just dealing with one singular package. And the memory limit is theoretically 128 megabytes for a single durable object instance. And I think things do get weird when you start reading more than like 10, 15 megabytes into memory. But in our case, most packages are underneath that by a mile. Yeah.
So each package is an instance of a durable object now in our architecture, meaning if someone uses kind of.
Yeah. So like the durable object. So at the end of the day, what we need to do, it's kind of like we built, I thought of calling it FPM, like Fiberplane package manager, but that was just kind of cheesy. We kind of have a mini package manager. And it's not very smart yet. And what it does is that, so when you create your app, we kind of derive a package.json from it, just based off of whatever your imports are in the app. After that, we parse out all the dependencies from that package.json. So they have a dependency and a version. And then for every single package and version combination, we create a durable object instance. And that durable object instance is responsible for fetching the package, decompressing it, untarring it, and then uploading all of its files into R2, which is Cloudflare's blob storage, like an S3. Then we add a little like metadata field to that kind of package in R2. And once the files are in R2, it makes it easier for both our TypeScript compiler and for our bundler to get the necessary things that they need in order to do their jobs. So, yeah.
Sorry, sorry, needs to interrupt, but that means also, for example, if I now use codegen and I prompt it with a package no one else has used in codegen before, it will do all of that. But then the next time another user that's not me comes and wants to use the same package, it uses this thing that it has stored in R2 already.
Yep.
So theoretically, if we have more people asking for more packages, our small internal Fiberplane package manager will have will get more packages, right? Is that like a correct understanding of mine? Yeah. Okay.
Yeah. So this we can also chalk this up under the improvements column, which is you can put like a TTL on all of your entries in R2, and so that we don't have an infinitely ballooning, blob storage full of packages. That we could instead just like purge it after 30 days, 10 days, something like that, and then that keeps our storage costs down. Under the hood, kind of an interesting, again, this is kind of like high-level architectural stuff, but thought it was fun to share. So with a durable object, that when you create an instance of that, it's created, I believe, as closely as possible to where the worker that invoked it lives. So a user in Australia makes a request that probably hits a data center in Australia, the worker. The worker is going to create create these durable object instances for a package. And so if it's the first time that durable object instance is created, it will be created in Australia. It will always live in Australia. It's not replicated or anything like that. This just has to do with distributed systems. And so what we decided is at the end of the day, we have that metadata field in R2 that we kind of put into the kind of package key. And that is like our cache. So anytime that you are requesting a package, it looks for that metadata field. And if it exists, it knows like, okay, I have this package in R2 and I can proceed. And the reason we do that is because R2 is kind of, strongly consistent globally, it would be the term. So that first fetch to R2 is very likely going to be faster than a first fetch to a durable object to see if it already exists and fetch the package. And so in the case where it's already in R2, whoa, hello.
So if it's already in R2, we don't need to create a durable object to fetch the package, right? So, okay.
Indeed.
That's cool.
And I don't know if I want to necessarily show the code because it's messy because we made it in a couple of days.
That's why you were like, woo.
Yeah, but
it's okay.
The durable objects themselves, this would be another improvement. We should probably evict them, destroy them, whatever, after a certain amount of time, because they always live. But they do have some like a little bit of caching inside of them as well, which is like they know if they've processed the package. And so if there are certain code paths where it's like we just want to check if a bunch of packages exist, we can also just shell out to all the durable objects, and then they will tell us where the thing is in R2, and we can go and fetch it.
But what I see in the so in the mermaid diagram, when I see the catch misses, this is all the paths when I create or get the package, initialize the durable object, and this is all the durable object paths.
Yeah.
And then can you scroll down? The catch hit is basically it just uses the package from the it returns from R2. Okay, cool. That's super cool.
Yeah, the one kind of interesting one interesting pattern with durable objects is maybe I just show the code. Durable object. Okay, not good code. Just everyone know. So we create a durable object. It has some state on it, like it needs to know what its package name is and what its package version is. And interestingly, let's see if I can find. No. Okay, so we create that in fetch package. So we have to go through this, like we get the ID from the name right here for this durable object instance, and then we get the stub of the instance, so like something that we can actually talk to. And something that tripped me up in the past with this kind of workflow is that so this package key is like the name and the version, and I want the durable object to be aware of this name right here, but it's not actually. And that's why we call this initialize right here. So like what I really want is that as soon as this thing is created, I want to populate the package name and package version field, but that is not possible. Even though I created the ID for this thing from a package name and a package version, I can't really reverse engineer that as far as I understand. So we have, where is it? Initialize. This initialize function, which allows you to, I think this is a pretty common pattern. It allows you to like set that kind of information on the durable object itself so that it knows like, okay, I'm the durable object that represents this package and this version of this package. And then we wrap the creation of the durable object and any interactions with it in a function that whenever it grabs this stub, it tells it immediately, this is your name and this is your version. And then that way we have a kind of a guarantee that the durable object knows who it is, if that makes sense.
Yes, quick question in between. Sorry,
Yeah.
that came to my mind. But okay, once the durable object has fetched the package and stored it in R2, as far as I understand from the diagram, the durable object is not needed anymore, right? Because then it lives in then the package lives in R2, and whenever the next user asks for this specific package with version, it will goes to the R2. Does the durable object, the instance, stay still alive? So are we creating a lot of durable objects that are not having any work afterwards anymore? Do you know what I mean, kind of?
Yeah. But they are hibernated. So I think we're only paying for the storage, because I think you pay for storage and CPU time. I can't really remember anymore. I need to look this up.
I don't know. But they are like theoretically they still exist. We don't close them or kill them, but they don't produce any extra cost for us. That's what you want to say?
They might produce storage costs, but they don't produce CPU costs because they are sleeping.
But is there a reason why we put them sleep and not like delete them afterwards? Would that
we
be?
Probably should. I think. Okay. So this is showing my cards. I think not all code paths that we have. Why do I keep double clicking things? I know it's a bad idea. Not all code paths that we have solely rely on looking at the R2 cache. I think some of them just check the DOs directly. I need to check the code again. So as I'm talking this through, I'm like, yeah, maybe we can evict the DOs. And I think Nella just improved our code base.
Maybe not. Maybe there's a reason, right? But I was wondering if the only task of it is to fetch it and store it in the R2, and once that's stored, maybe.
Yeah. So this is the two improvements that I have, and actually I'm going to put another on. Set durable object alarm to clean up. Okay, so now there's three improvements. One is what I mentioned at the beginning of doing streaming tar parsing. So you get a tar, you get a compressed tar from when you fetch the package, you decompress it, and then you like what we do right now is we untar the whole thing, but we could do that in a streaming way where every time that a new file is available, we just like upload that file. And then that way we don't have to hold the entirety of it in the memory of the durable object. We had troubles with a tar parsing library, and then just like yesterday, I found one that the Remix team put out. So that's just a JavaScript framework that's getting rewritten from the ground up, only using web standards. So the cool thing about if it's only web standards, it's going to work on Cloudflare. And they have a streaming tar parser that I did not know existed because it's very new.
I'm confused, but Remix is called now React Router, no?
Yeah, that is it's so confusing. I don't like, they're brilliant people and terrible at names. That seems to be a trend in our field. They are making a new version of Remix that's a complete rewrite. So Remix was merged into React Router, and then now they're recreating Remix, and it's not confusing at all.
Okay, so I get it. So the old Remix is called React Router now, but
yes,
a new Remix is called Remix, and Remix will be something completely different than the old Remix.
Exactly. And with very cool design philosophies. I guess that's not the topic of the stream, but I was like, I heard about it, and I was kind of interested in it because I heard that it was all web standards based, and I used AI tooling very heavily in my day-to-day. So I sent off Perplexity to do some research. And I was like, okay, look at GitHub activity by the creators of Remix, look for any utilities that they've been making, and found a repo on GitHub with those utilities. And when I looked through, I found a streaming tar parser, and I was like, ooh, we could use that.
That's cool. Okay, quick other question, Brett, because we've been on the diagram on the left-hand side, and I see there's a right-hand side on the diagram. I feel you should briefly explain to me what the right-hand side of the diagram is. I think I need to add this again to.
Okay. Yes.
Or if you share again, I can add
I am
it.
sharing. Okay.
I was
I think
wondering. Maybe someone who's watching is also wondering.
I think the right-hand side is just supposed to illustrate like the parallelism. So
okay.
Yeah, like say that you have Lodash version 4, 17, 21. That creates a DO for that specific version, and then that puts it in R2. And repeat that process for all and any packages.
But it's not like the Mermaid diagram goes there for each package, and then it's the either or package manager. It's like doing both at the same time, right? So
So
okay.
these parallel processes. This is kind of a confusing diagram now. You mentioned it. I whipped it up real fast.
But it's good that we have a diagram, because I think I have a better time understanding now how it works. But
yeah, I think then the other two things are just cleaning, like, we'll implement them very soon, but just cleaning things up for our sake. So cleaning up durable objects and then cleaning up packages in R2 so they don't stick around forever.
Nice. And one last question.
Yes.
I mean, I know we ran into this issue in the London hackathon. We had rate limit issues. And
yes.
I think also we used the AI Gateway from Cloudflare to overcome those, right? Can you tell me a little bit what we engineered there, or what the team was doing?
Yeah, so we use Cloudflare's AI Gateway. So we get logging from that, which is helpful. This shout out to our colleague Benno, who found. So we use the Vercel AI SDK under the hood.
Mm-hmm.
And there's a community provider that wraps AI Gateway calls, which is very nice. I did not know that, and I had written a lot of custom stuff to be able to add metadata to the gateway and stuff like that. So once we implemented that provider, that gave us the possibility to do failover. And failover is just if one provider is down, or if you're hitting your rate limits, you can fall back to another provider. It's a very good practice to have. There's a couple of dangling things we need to resolve, but so the day of, we realized we really needed failover. Just the math was not working for us to survive the event without things breaking, and basically all we had to do is define, in addition to defining, so I'll show the code. It's going to be, I wanted to avoid showing code again, but it's just so much easier to see. Share screen. I hope I'm not revealing any. Okay, wait, it's utils. Revealing any trade secrets here. This should not be. Oh, this is not the one. Utils. Is this it? Oh, where is it? Oh, yeah, here it is. Okay. Sorry, it's just a very big file. Okay, so we have this wrapper function, and we can create an Anthropic model that is normally, I guess, trade secrets, but not that secret is, we're using Claude Sonnet 4 and GPT 4.1. We create the Anthropic model, and we also create an OpenAI model, but then we wrap it in this AI Gateway right here. And then that is a library that Cloudflare produced that allows us to send requests to them more easily with metadata attached and things like that. And so the thing that I uncovered when I dug into the source code is that what's happening under the hood is it sends off all the data it needs to make both requests. And so, and then the gateway tries to make the first request, and if it fails, it goes back to the other provider. So it's not like a multiple round trips. It's not like the AI Gateway makes, or it's not like in your code base you're making a request to the gateway, the gateway says that failed, and then in your code base, you know it failed, and then you fall back to the other one, which I think is kind of a neat feature. It saves round trips. Now, the thing that I've not cracked yet is that typically when you switch providers like this, you want to tweak the prompt a little bit. And I have not figured out how to change some of the behavior or prompting between the two models if we encounter a scenario where we're falling back to OpenAI.
And we want to change the prompt because a model acts a little bit differently, and it needs maybe a little bit different of like instructions or I don't know, a different prompt basically.
Yeah, so a good
better results.
A good example here, I'm going to stop sharing my screen. A good example here is how to do text editing. How to do text editing when you are using Anthropic models. It's kind of like a specific tool that Anthropic has developed that's very good at string replacements and line insertions and things like that. And I'm certain they've done post-training on Sonnet 4 to be able to make it really snappy. So it can analyze a file, look where it needs to add text, and then add it. OpenAI has no equivalent, and writing like a translation layer for that tool is difficult. And then there's no guarantee that OpenAI's models have been trained to use that tool as well. Now, OpenAI's approach to text editing is using something called predictive outputs, where it's like you give it the entire file that you want to edit, and then you kind of describe the edit you want to make. And then there's some like machine learning magic under the hood where it's like the model knows that like all the tokens that are in the file you gave it are, I'm doing crazy hand gestures. The model knows.
The LLM knows.
The model knows like, I don't want to be mathematical. It like knows the probabilities of encountering tokens in that document are very high. So it's like it like limits the world that it's thinking in, and it's able to like respond really, really fast with whatever edits it's going to make. And it also is cheaper. OpenAI gives it kind of a discount, I think, for that thing called predictive outputs, I think. But it's mainly like a latency thing. So like regenerating the file is like 10 times faster when you are giving it a file / an edit command. And so like those two differences, those are things we would really want to account for when we switch providers. And I just haven't had time to look into how to do something like that with this setup. Yeah.
Okay, the next time, Brad, we have to, like, when you start talking about LLMs and the differences, we put a crystal ball in front of you, so your hand, like, Gemini, what do I see here? Or like Anthropic models, I don't know, sorry. But I was thinking of this crystal ball, like, that is missing in front of you now. No, but it makes sense. Sorry for the crystal ball.
Yeah.
But that is cool to hear. It's interesting. And I think that's also the interesting part. While we start learning more and building more with users, we will hit more of those things and we'll go deeper and change our code. I'm looking forward to that, actually. I think that's really interesting. And I think next week you might join me again. Like, so let's see.
Yeah. Next week will be a little different. It'll be less of me rambling.
No, next week will be super interesting because I'm not good in front-end engineering, but I did something on a front-end side, like a landing page. And that's like no back-end this time, only front-end. And you can probably go with me through the code base and we can discuss what me and Windsurf did correct and what you would change. I think that could be interesting.
Yeah, I love a good vibe code, and I also love seeing where it's awesome and where it's not. So yeah, that'll be. Although like, yeah, you have to tell me in advance which parts you worked on a lot, so I'm not like, well, this is not good. That darn AI.
Oh no, that's okay. I mean, I will.
Or maybe I praise it a bunch, and then you're like, well, actually, I wrote that.
It's like, no. That's all good. I think it's I just want to share how my process was, how my thinking around it was, and I think then maybe we can also discuss how you normally approach those things, and that's sometimes interesting with all those new tools around there and different approaches. So yeah, but that's on our plate for next week. And then once we have other architectural changes in our platform, I would love you to come back so we can talk about them. I'm also curious to find out what we do with those durable object instances. And yeah.
I'm also curious. It's probably a good motivation for me to do the things I'm supposed to do before coming back on. And I forgot. Wait, so two things. Just like too little, too late. But I realize it's like kind of probably random why it's just this. It's a honk out stream, and it's just a big architectural discussion. But at the end of the day, Fiberplane's codegen platform is a honk app. It's a very grand, large honk app, and this is how we're building it. So it feels relevant.
And I mean, we can talk about different things, right? And Cloudflare is one part of the Honc stack. And
That's
then
true.
if you build more things on Cloudflare, you need more architectural decisions. Maybe not in a simple Honc app, but then if you, as you said, build something like us, more complex, you will probably have those discussions as well.
Yeah. And then the second thing is, I don't know if I've worn this shirt or shown this shirt on the stream before, but it's
oh my god, I love it.
I just like impulse ordered it off of Amazon last fall, and I always thought it is like, I don't understand it, to be frank. I don't understand if it's like a joke I don't get, but I kind of like jokes that I don't get. So I was like, oh, that seems funny. And I was walking. My dog is with me in the meeting booth right now, and I was walking her earlier, and someone on the street like whispered, or not really whispered, but like said audibly, like, "Oh, that's a great shirt." And I was like, "Really?"
You're like,
didn't say it to me, but like to her friend. And I was like, "Yeah, okay, cool. Someone gets the joke that I don't get."
I mean, I was just seeing the goose, pretend I'm a goose. I was like, oh my god, that's genius. Like, we have the goose in the office, and we sit you next to the goose with your t-shirt. Or we make our goose wear this t-shirt. I don't know.
Actually, wait, yeah, the goose should totally wear this. Pretend I'm a goose.
Yeah. Well, and yeah, I think let's wrap it up, and let's meet people again next week. And yeah, I would end the stream, and we still have no jingle.